Hi Year 5, welcome to Term 4 where we are going to be ready to kickstart those fractions once more. We've got a couple more weeks of them and I know we're going to absolutely smash it. Okay, so let's start with a mental arithmetic starter to get those brains warmed up after a week off. Okay, don't worry if it takes you a little bit longer here. Okay, pause me and then come back whenever you're ready for me to reveal the answers. Okay, so here we go. First one, you would have gone, how many groups of 3 can I make out of 11? Would have been 3 with 2 left over, which would be 3 2/3. This one, you do the same to the bottom as the top. You multiply the numerator and numerator and denominator by 3 to get 21/30, etc. I'm going to stop trying to explain them because clearly I'm having a bit of a nightmare. Right, today is all about, and the next few days are going to be all about subtracting fractions. Last time we spent a lot of time looking at adding them. So we've got a little warmer for you to have a go at completing these calculations. Now, think back, we did do a little bit of subtracting. What do you remember about doing them? If you're not sure, I've put our steps to success down here. Pause me, have a little go yourself. And then I will do I'll show you the answers and I'll do a worked example if you're not sure. Okay, so it's essentially exactly the same as adding, except we're doing subtracting. So step 1, 2 and 4 completely stay the same. So if we look at A, 3/4 take away 16/32, we need to make sure we find the lowest common denominator. Now, 2 ways I could list my 4s and my 32s. I know that 32 is in the 4 times table, so I could just change this to 32. I could also divide this one, but let's go with doing it by multiplying to kind of make it simpler. So if I'm turning 3/4 into 32, I'm going to times by 8. Same to the bottom as the top, I'm going to get 24. If I do 3 times 8, okay, so then I'm going to do 20, that's step 2. Step 3, I'm going to do 24/32 to take away 16/32. The bottom stays the same. The top will be 24 take away 16, which is 8. And then my step 4, can I simplify by dividing? This is probably the bit that you guys maybe find trickiest. We're going, is there a times table with both these numbers in? Actually, yeah, the 8 times tables. So if I do 8 and 32 both divided by 8, I'll get the answer. 8 divided by 8 is 1. 32 divided by 8 is 4. So my answer is, I believe, 1/4. Yeah, there we go. So there's your answers. You've got them before they're simplified here. And then these have all then been simplified by dividing. Okay, if you got this bit, but you didn't then simplify it, can you pause me here? Have a go, see if you can work out how we would change 7/56 into 1/8, for example. When you're ready and you're comfortable with that, let's move on to the next section. So if we look at a little bit more detail, one of the ways we can do subtracting is on a number line. It's something you would have learned way back when, probably in year 1. So remember, subtraction is basically a way of finding the difference between 2 numbers, kind of the distance between them if they were on a number line. So we've got what is the difference between 7/10 and 1/5. It's asking us what is that kind of space between them. And I can use a number line to help. Okay, so if we look here, I've got a number line, I've got 0 at one end, 1 or a whole on the other. So we know both of these fractions, they're proper fractions, they'll be in between. If I look at how my number line's been broken up, it's been broken into 10 steps. So I can go 1/10, 2/10, 3/10, etc. all the way to 4, 5, 6, 7/10 is going to be here, okay? Because that's how my number line works. It's equal steps up to there, okay? Now, the tricky thing with 1/5 is I'm not quite sure where it would fit on a number line that's split into tenths, if that's 1/5. So same as, you know, something we've had tons of practice at the moment, I'm simply going to turn 1/5 into tenths so I can see where it would be on my number line, okay? And I know to turn fifths into tenths, I would multiply 5 by 2 to get 10. Do the same to the bottom as the top. And 1 times 2 is going to be 2. Okay. So if I'm putting 1/5 on my number line, that's either I can put it as 2/10 here, or I can write it out as its original fraction. I'll do that at the top. 1/5 there. All right, hopefully that makes sense. So you can see I've put both on my number line. Next thing for me to do to find the difference is I'm literally going to count the steps in between them. Remember, what are my steps? They're going up in tenths, aren't they? So I'm going to put that down here. Tenths is my denominator. Let's see what the distance is between them. I'll change colour just for a laugh. There we go. So we're going to go 1, 2, 3, 4, 5. There are 5 jumps between the two. So I'd write that as 5/10. I could also simplify that, couldn't I? So the difference is either 5/10, or if I wanted to simplify, both 5 and 10 are in the 5 times table. So if I divided those by 5, 5 divided by 5 is 1. 10 divided by 5 is 2. So the difference between 7/10 and 1/5 is 5/10 or 1/2. Okay, so why don't you I'm going to show you an example that I'd like you to have a go here. So your turn. Can you find the difference between 2/3 and 3/9? Tip, I've put my number line with the highest denominator, sorry. I've cut my number line into ninths, okay? So why don't you have a little go there for me? Pause me. You've got my example as a worked example here. See if you can find the answer, okay? Okay, so hopefully you drew out your own number line, because this one actually isn't split into ninths. But if you did, I would have changed 2/3 into 6/9. I would have found the distance between 3/9 and 6/9 would have been 3 jumps, so 3/9 between them, and that could have been simplified into a third. Okay, so again, some of you really like number lines. I quite like them. They're easy to visualize. However, some of you might prefer kind of our mental methods instead. Okay, so let's have a little look here. We've got the bar model this time. What do we need to do to the denominator before we subtract? We've got 3/4, take away 3/8. I can't do the calculation unless my denominators are the same. So I'm going to change. I could find my lowest denominator. I know that 8 is in the 4 and the 8 times tables. Therefore, that's my step 1. Step 2 is going to be turning 3/4 into 8. How would I do that? Hopefully you guys can remember. Well, I've multiplied that by 2. Same to the bottom as the top. 3 times 2 is going to be 6. Okay, so 3/4 is the same as 6/8. So now what I'm doing is 6/8 take away 3/8. Now again, you can probably do that really easily mentally, but let me just show you it on a bar model. So I've got my bar. It's cut into 8 parts because I'm dealing with 8. I've shaded in 6 of them because 6/8 is the number I'm starting with. If I then got rid of, if I took away my 3/8, so 1, 2, 3, get rid of them, I'd be left with 3/8. Okay, again, it's just another helpful way, I'd say, of visualizing it. If we just checked it with our kind of mental method by doing 6/8 take away 3/8, we do 6 take away 8. 6 take away 3 would be 3. There we go, we got the same answer. So why don't you, again, I'd like you to pause me, have a go at this question, either with or without a bar model, and then I'll reveal both of them, the answer and the bar, to you in a bit. Okay? Okay, troops. So if I show you my bar, converted 1/5 into 3/15. If we look, I've got my bar split into 15ths, 9 shaded. I've got rid of 3 of them because that's equivalent to 1/5, 3/15. My answer would be 6/15 left, which if I simplified by dividing both by 3, I would end up with 2/5. Okay, so the answer is 6/15, or in its simplest form, 2/15. Right, just have a look at these calculations. What do you notice? Which one do you think would be easier? Do you notice anything with the others? Have a go, have a look. Right, well, if I look down this side, straight away, I can see that the answers, I've got the same denominator, so that's going to be nice and easy. However, I've also noticed that the calculations over here match up to over here. So look, 9/10 take away 1/5. I would change 1/5 to 2/10, and that would be that. 5/6 take away 12/18. If I multiplied that by 3, this first one, the bottom and the top, I'd end up with 15/18 to take away, which means this one over here could have turned those both just into 16ths, but here we've changed them into 32ths. Okay, so hopefully you've seen those links, and it's all about just making sure you've got the same denominator, and then you can just subtract the numerator. Okay. Right. Got a word problem here I'd like you to have a go at, please. It is a little bit spicy, but I reckon you can do it. No trouble. Have a little read through. Why don't you do rucksack? Pause me, and then I'm going to show you the answer and talk through how you'd have got there. Okay. If you're finding this ultra spicy, then don't worry. You don't have to have an attempt now. You could always come along to your drop-in session to have a go later. Okay. Right, those of you that paused me and had a go then, let's just have a little look-see. So Monday she read 4/7 of an hour. Not sure how many minutes that would be. On Tuesday she reads for 3/14 of an hour less than Monday. So we're taking away 3/14 from the 4/7 to find out what she read on Tuesday. So what would that be? 4/7 would be 8/14, take away 3/14. Tuesday she read 5/14 of a book. You can check my maths if you're not sure. Like I said, we can daily drop in it later. So then the question's asking me, how much did she read altogether? So it's a multi-step question. Now I need to add together, if I actually put it there, I need to add together what she read on Monday, 4/7, and what she read on Tuesday, 5/14. Easy peasy, I can turn 4/7 into 8/14. Oh gosh. Pen went a bit wild there. And then I do 8/14, add my 5/14. That would give me 13/14. She spent 13/14 of an hour reading on Monday and Tuesday altogether. Luckily, guys, we don't tend to talk about that. I think a quarter of an hour is probably about as far as I go when I talk about fractions and time. Okay, so a bit of a weird question, but hopefully it got your brain thinking. Right. Finishing off then, as always, we've got some fluency here. This is also on the website. I'd really like it if you could have a go at these questions, following the steps. I tell you what, let me just pause and I'll add our steps to success on the screen so you can see them. Ta-da! I'm back. Yeah, have a go at these fluency questions, please. You've got your steps to success just there. Once you've done them, I will then reveal the answers. Plus, there's also some problem solving and reasoning additionally on the website. Okay, good luck. Like I said, don't worry if your brain's a little bit rusty today. We will get them all warmed up for you. Okay, so pause me here and then I'll show you the answers. All right, troops, here they are. Again, the answers are also on our website. They're on the second page of the Fluency where they'll always be. Here they are if you wanted to check them live with me. Not live, with me. If there's any you're not sure, if you got one wrong and you can see your marvellous mistake, no probs. If you got a couple wrong and you're not quite sure where you went wrong, come along to our daily drop-in and we will get you back on track. Okay? Have a lovely day. We'll see you soon. Bye-bye.